Lightning follows a zigzag path instead of a straight line due to complex electrical, atmospheric, and physical phenomena. To understand this fully, we need to explore several layers of scientific explanation, including electrical discharge physics, air ionization, electric fields, and charge dynamics. Here's a comprehensive and detailed explanation. Lightning. The basics: lightning is a giant spark of electricity caused by a difference in electrical charge between clouds and the ground, or between clouds. It occurs when the electric field strength exceeds the breakdown voltage of air, allowing current to flow in the form of a plasma channel. What causes the electric field? Inside a thundercloud, ice particles collide and build up charge. Heavier, negatively charged particles sink to the bottom of the cloud. Lighter, positively charged particles rise to the top. The ground beneath the cloud becomes induced with positive charge due to this separation. This charge imbalance creates a very strong electric field, often exceeding 3 million volts per meter, which is enough to ionize air molecules and start a discharge process. Why air doesn't conduct electricity? Easily under normal conditions, air is an insulator. Molecules like nitrogen and oxygen do not allow electrons to flow freely. But when the electric field becomes intense enough, it ionizes air molecules, creating a plasma. This means electrons are knocked free from atoms, creating free electrons and ions. This ionized region becomes conductive. Still, this ionization doesn't happen uniformly, and that is the key to the zigzag pattern. The stepped leader. The secret behind the zigzag: before you see the bright flash of lightning, there's an invisible process called the stepped leader. How the stepped leader works: ionization begins when the electric field gets strong enough. A small segment of air breaks down and ionizes. Step formation. The leader doesn't travel in a straight line. It moves in discrete steps, typically 50-100 meters at a time. Zigzag path. After each step, the path pauses for a few microseconds while the next step forms, seeking the path of least resistance. Branches form. At every stage, multiple potential directions are tested. The strongest one continues, creating the jagged tree-like branches. The result? A zigzag, forked appearance, as the leader tries multiple paths through a highly variable atmosphere. Why doesn't it just go straight? Because air is not uniform. Many factors influence how electricity moves through it. Density variations in the atmosphere. Air has pockets of different humidity, pressure, temperature, and particle concentration. These pockets affect how easily the air can be ionized. Some regions offer less resistance than others. Electric field irregularities. The electric field is not uniform. It's distorted by terrain, buildings, trees, and ionized air paths. The lightning channel bends toward areas of stronger electric field, which may not lie in a straight line. Electron avalanche. As free electrons move, they collide with neutral atoms, knocking off more electrons in a chain reaction. This electron avalanche takes the path where conditions are most favorable, often deviating from a straight line. Path of least resistance. In physics, electrical discharges follow the path of least electrical resistance. That path is rarely a straight line because of air turbulence, impurities, charged particles, and changing atmospheric conditions. Final flash. The return stroke. Once the stepped leader reaches a region with an opposite charge, often the ground, the path is completed. A return stroke, a powerful burst of current, races upward through the established zigzag channel. This return stroke is what you see as the bright lightning flash. It follows the pre-ionized zigzag path created by the stepped leader, which is why lightning appears jagged. Scientific summary: phenomenon explanation: air ionization. High electric field breaks down air into plasma. Stepped leader. Lightning grows in jumps, not continuously. Electric field lines. Lightning bends to follow strongest. Electric field. Inhomogeneous atmosphere. Varying temperature, humidity, and pressure cause zigzag. Branching and path. Selection. Multiple branches form, strongest continues. Real-world analogies. Think of lightning like a tree root growing through rock. It seeks the weakest points, not a straight line, or like water trickling downhill. It meanders through the easiest path, shaped by terrain. Conclusion: lightning doesn't travel in a straight line because the atmosphere is complex, not homogeneous. It moves in discrete steps, stepped leader, not a smooth path. It continuously seeks the lowest resistance route through the air. The electric field strength and direction vary based on conditions. These combined effects make the path zigzagged and branched, not straight. This complex behavior is a result of plasma physics, atmospheric science, and electric field dynamics working together in one of nature's most spectacular displays.